The Earth, our habitat. This is the lesson number 2. Globe, latitudes and longitudes. From page number 10 to page number 17. Let's listen to the lesson number 2. Globe, latitudes and longitudes. Page number 10. In the previous chapter, you have read that our planet Earth is not a sphere. It is slightly flattened at the north and the south poles and bulged in the middle. Can you imagine how it looks? You may look at a globe carefully in your classroom to get an idea. Globe is a true model, that is, miniature form of the Earth, as shown in Figure 2.1. Figure 2.1 shows a globe. Globes may be of varying size and type. Big ones, which cannot be carried easily, small pocket globes, and globe-like balloons which can be inflated and are handy and carried with ease. The globe is not fixed. It can be rotated the same way as a top spin or a potter's wheel is rotated. On the globe, countries, continents, and oceans are shown in their correct size. It is difficult to describe the location of a point on a sphere like the Earth. Now the question arises as to how to locate a place on it. We need certain points of reference and lines to find out the location of places. You will notice that a needle is fixed through the globe in a tilted manner, which is called its axis. 2 points on the globe through which the needle passes are 2 poles, North Pole and South Pole. The globe can be moved around this needle from west to east, just as the Earth moves. But remember, there is a major difference. The real Earth has no such needle. It moves around its axis, which is an imaginary line. Another imaginary line running on the globe divides it into 2 equal parts. This line is known as the equator. The northern half of the Earth is known as the northern hemisphere, and the southern half is known as the southern hemisphere. Let's do. Take a big round of potato or a ball. Pierce a knitting needle through it. The needle resembles the axis shown in a globe. You can now move the potato or the ball around this axis from left to right. Page number 11. They are both equal halves. Therefore, the equator is an imaginary circular line and is a very important reference point to locate places on the Earth. All parallel circles from the equator up to the poles are called parallels of latitudes. Latitudes are measured in degrees. The equator represents the 0-degree latitude. Since the distance from the equator to either of the poles is 1/4 of a circle round the Earth, it will measure 1/4 of 360 degrees, that is 90 degrees. Thus, 90 degrees north latitude marks the North Pole and 90 degrees south latitude marks the South Pole. Figure 2.2 shows latitude. We can see the North Pole, 80 degrees north latitude, 60 degrees north latitude, 40 degrees north latitude, 20 degrees north latitude, equator, 20 degrees south latitude. As such, all parallels north of the equator are called north latitudes. Similarly, all parallels south of the equator are called south latitudes. The value of each latitude is, therefore, followed by either the word north or south. Generally, this is indicated by the letter N or S. For example, both Chandrapur in Maharashtra, India, and Belo Horizonte in Brazil, South America, are located on parallels of about 20 degrees latitude. But the former is 20 degrees north of the equator and the latter is 20 degrees south of it. We therefore say that Chandrapur is situated at 20 degrees north latitude and Belo Horizonte is situated at 20 degrees south latitude. We see in figure 2.2 that as we move away from the equator, the size of the parallels of latitude decreases. Important parallels of latitudes. Besides the equator, that is 0 degree, the North Pole 90 degrees north and the South Pole 90 degrees south, there are 4 important parallels of latitudes. 1. Tropic of Cancer 23.5 degrees north in the northern hemisphere. 2. Tropic of Capricorn 23.5 degrees south in the southern hemisphere. 3. Arctic Circle at 66.5 degrees north of the equator. 4. Antarctic Circle at 66.5 degrees south of the equator. Figure 2.3 shows important latitudes and heat zones. We see North Pole, frigid zone, then comes Arctic Circle at 66.5 degrees north, then comes North Temperate Zone, then comes Tropic of Cancer at 23.5 degrees north, then comes Torrid Zone, then comes Equator at 0 degree, then comes Tropic of Capricorn at 23.5 degrees south, then comes South Temperate Zone, then comes Antarctic Circle at 66.5 degrees south, then comes frigid zone, and then comes South Pole. Do you know, by measuring the angle of the pole star from your place, you can know the latitude of your place. Heat zones of the Earth. The midday sun is exactly overhead at least once a year on all latitudes in between the Tropic of Cancer and the Tropic of Capricorn. This area, therefore, receives the maximum heat and is called the torrid zone. The midday sun never shines overhead on any latitude beyond the Tropic of Cancer and the Tropic of Capricorn. The angle of the sun's rays goes on decreasing towards the poles. As such, the areas bounded by the Tropic of Cancer and the Arctic Circle in the northern hemisphere and the Tropic of Capricorn and the Antarctic Circle in the southern hemisphere have moderate temperatures. These are therefore called temperate zones. Areas lying between the Arctic Circle and the North Pole in the northern hemisphere and the Antarctic Circle and the South Pole in the southern hemisphere are very cold. It is because here the sun does not rise much above the horizon. Therefore, its rays are always slanting and provide less heat. These are therefore called frigid zones. That is, very cold. Figure 2.4a shows that a torchlight falling on a straight surface is bright and covers a smaller area. Figure 2.4b shows torchlight falling on a slanted surface is less bright but covers a bigger area. What are longitudes? To fix the position of a place, it is necessary to know something more than the latitude of that place. You can see, for example, the Tonga Islands in the Pacific Ocean and Mauritius Islands in the Indian Ocean are situated on the same latitude, that is, 20 degrees south. Now, in order to locate them precisely, we must find out how far east or west these places are from a given line of reference running from the North Pole to the South Pole. These lines of references are called the meridians of longitude, and the distances between them are measured in degrees of longitude. Here in figure 2.5, we see longitudes. Starting from the North Pole, moving ahead in a clockwise direction, we see 150 degree east longitude, 120 degrees east longitude, 90 degrees east longitude, 60 degree east longitude, 30 degrees east longitude, 0 degree longitude, 30 degrees west longitude, 60 degrees west longitude, 90 degrees west longitude, 120 degrees west longitude, 150 degrees west longitude, 180 degrees longitude. Page number 13. Each degree is further divided into minutes and minutes into seconds. They are semicircles, and the distance between them decreases steadily polewards until it becomes 0 at the poles where all the meridians meet. Unlike parallels of latitude, all meridians are of equal length. Thus, it was difficult to number the meridians. Hence, all countries decided that the count should begin from the meridian which passes through Greenwich, where the British Royal Observatory is located. This meridian is called the prime meridian. Its value is 0 degree longitude, and from it we count 180 degrees eastward as well as 180 degrees westward. The prime meridian and 180 degrees meridian divide the earth into two equal halves, the eastern hemisphere and the western hemisphere. Therefore, the longitude of a place is followed by the letter E for the east and W for the west. It is, however, interesting to note that 180 degrees east and 180 degrees west meridians are on the same line. Now, look at the grid of the parallels of latitude and meridians of longitude on the globe as shown in figure 2.6. You can locate any point on the globe very easily if you know its latitude and longitude. For example, Dhubri in Assam is situated at 26 degrees north latitude and 90 degrees east longitude. Find out the point where these two lines cut each other. The point will be the location of Dhubri. To understand this clearly, draw equidistant vertical and horizontal lines on a paper as shown in figure 2.7. Label the vertical rows with numbers and horizontal rows with letters. Draw some small circles randomly on points where these horizontal and vertical lines intersect each other. Name these small circles as A, B, C, D, and E. Let vertical lines represent east longitudes and horizontal lines as north latitudes. Now you will see that circle A is located on B degree north latitude and 1 degree east longitude. Find out the location of other circles. In figure 2.6, you can notice the grid. It shows North Pole, prime meridian, 60 degrees west latitude, 30 degrees west latitude, 0 degree, 30 degrees east latitude, 60 degrees east latitude, equator, 0 degree latitude, 80 degrees north longitude, 60 degrees north longitude, 40 degrees north longitude, 20 degrees north longitude, 20 degrees south longitude, and 40 degrees south longitude. Page number 14. Figure 2.8 shows time zones of the world. On the map, it has been marked Greenwich, time zones ahead and before. Page number 15. Longitude and time. The best means of measuring time is by the movement of the Earth, the Moon, and the planets. The sun regularly rises and sets every day, and naturally, it is the best timekeeper throughout the world. Local time can be reckoned by the shadow cast by the sun, which is the shortest at noon and longest at sunrise and sunset. When the prime meridian of Greenwich has the sun at the highest point in the sky, all the places along this meridian will have midday or noon. As the Earth rotates from west to east, those places of east of Greenwich will be ahead of Greenwich time, and those to the west will be behind it, as shown in figure 2.8. The rate of difference can be calculated as follows. The Earth rotates 360 degrees in about 24 hours, which means 15 degrees an hour or 1 degree in 4 minutes. Thus, when it is 12 noon at Greenwich, the time at 15 degrees east of Greenwich will be 15 multiplied by 4, that is equal to 60 minutes, that is 1 hour ahead of Greenwich time, which means 1 p.m. But at 15 degrees west of Greenwich, the time will be behind Greenwich time by 1 hour. That is, it will be 11 a.m. Similarly, at 180 degrees, it will be midnight when it is 12 noon at Greenwich. At any place, a watch can be adjusted to read 12 o'clock when the sun is at the highest point in the sky, that is, when it is midday. The time shown by such a watch will give the local time for that place. You can see that all the places on a given meridian of longitude have the same local time. Why do we have standard time? The local time of places which are on different meridians are bound to differ. For example, it will be difficult to prepare a timetable for trains which cross several longitudes. In India, for instance, there will be a difference of about 1 hour and 45 minutes in the local times of Dwarka in Gujarat and Dibrugarh in Assam. It is therefore necessary to adopt the local time of some central meridian of a country as the standard time for the country. In India, the longitude of 82.5 degrees east, that is, 82 degree, 30 minutes east, is treated as the standard meridian. The local time at this meridian is taken as the standard time for the whole country. It is known as the Indian Standard Time or IST. Figure 2.9 shows Indian Standard Meridian. That is 82.5 degrees east or 82 degrees 30 minutes east. On our right, we see 97 degrees east longitude, and on our left, we see 68 degrees east longitude. Page number 16. Kabir lives in a small town near Bhopal. He tells his friend Alok that they will not be able to sleep tonight. A day and night cricket match between India and England had started at 2 p.m. in London. This means that the match would begin at 7:30 p.m. in India and finish well into the night. Do you know what is the time difference between India and England? India, located east of Greenwich at 82 degrees 30 minutes east, is 5 hours and 30 minutes ahead of GMT. So, it will be 7:30 p.m. in India when it is 2 p.m. noon in London. Some countries have a great longitudinal extent, and so they have adopted more than one standard time. For example, in Russia, there are as many as 11 standard times. The Earth has been divided into 24 time zones of 1 hour each. Each zone thus covers 15 degrees of longitude. Exercises. 1. Answer the following questions briefly. A. What is the true shape of the Earth? B. What is a globe? C. What is the latitudinal value of the Tropic of Cancer? D. What are the 3 heat zones of the Earth? E. What are parallels of latitude and meridians of longitude? F. Why does the torrid zone receive maximum amount of heat? G. Why is it 5:30 p.m. in India and 12 noon in London? 2. Tick the correct answers. A. The value of the prime meridian is 1. 90 degrees 2. 0 degree 3. 60 degrees. B. The frigid zone lies near 1. The poles 2. The equator 3. The Tropic of Cancer. C. The total number of longitudes are 1. 360 2. 180 3. 90. D. The Antarctic Circle is located in 1. The Northern Hemisphere 2. The Southern Hemisphere 3. The Eastern Hemisphere. E. Grid is a network of 1. Parallels of latitude and meridians of longitudes 2. The Tropic of Cancer and the Tropic of Capricorn 3. The North Pole and the South Pole. Page number 17. 3. Fill in the blanks. A. The Tropic of Capricorn is located at dash. B. The standard meridian of India is dash. C. The 0 degree meridian is also known as dash. D. The distance between the longitudes decreases towards dash. E. The Arctic Circle is located in the dash hemisphere. Things to do. 1. Draw a diagram of the globe showing the Earth's axis, the equator, tropics of Cancer and Capricorn, Arctic Circle and Antarctic Circle. For fun, draw and cut out 6 circles of the same size, approximately 3 cm radius, from cardboard. Mark diameters north, south, east, west and 23.5 degrees angles on each face of the circles as shown in the figure. Place the circle one on top of the other and stitch along the line NS. Now there are 12 semicircles. Let one semicircle represent 0 degree or Greenwich meridian, that is, prime meridian. The 6th semicircle from it will be the 180 degrees meridian. Between the 0 degree and 180 degrees, there are 5 semicircles on both sides, which are west and east longitudes 30 degrees apart. On 2 ends of the staple line, stick pins to represent the north and south poles. A rubber band around the model touching the EW points will represent the equator. 2 rubber bands touching the 23.5 degrees points, south and north of the EW points, will represent the tropics. The chapter 2 of total 8 chapters of the book ends here.